Hello class, welcome to the next segment in the week 4 material, and in this segment we're going to briefly talk about something called the Zor operator, but the main emphasis that we're going to focus on is going to be with the not operator. So the Zor operator is something that some other programming languages have, but it turns out that it is so useless that Python doesn't even have it. Zor is spelled X-O-R, and if we want to see what we would expect that to look like. So I'll just go ahead and show you how exactly that's spelled. It's just X-O-R, and that's read as Zor. And it's kind of the same idea as the OR operator, but in the case of the OR, where we require at least one condition to be true in order for the entire thing to be true, in the case of the Zor operator, we require exactly one condition to be true. So they can't both be true, but they also can't both fail. So exactly one of those conditions has to be true in the case of the Zor operator, exactly one condition has to be true in order for the entire thing to be true. And I've been writing software now for close to 11 years, and I think I may have used the Zor operator once in that entire time. So if you look at the times that I use the other three Boolean operators, or, and, or not, and compare it to the number of times I use the Zor operator, the Zor operator is kind of just there and not particularly useful. In fact, Python doesn't even have a Zor operator because that's how useless it is. But it does exist. If you, by some miracle, ever encounter it, that's just an explanation of what exactly it does. It's, like I said, you're probably never going to have to worry about it, but in case by some miracle or some misfortune you do have to worry about the Zor operator, then that's the Zor operator explained. Again, that's spelled X-O-R, and that's actually short for exclusive OR. And again, unlike the regular OR, which requires at least one condition to be true, Zor requires exactly one condition to be true. But that's just a little bit about the Zor operator. But now let's go ahead and actually start talking about the main emphasis for this segment, and that is going to be the not operator. And this kind of gets, if you really want to understand or take a look at the not operator, you have to get pretty deep into the idea of the theory behind Boolean logic, and this kind of also gets into the idea of Boolean algebra, which if you really want to learn more about that, then I'll let you, if you really want to learn more about that, then you can either ask me about it, but it's not something that you really need to know a whole lot about if you're actually going to be programming anything for the sciences or just regular software development in general. It's just kind of a theory that we like to tell students about, and it's really just a lot of fancy symbols that really don't come into play very often. It's not something that you're really going to have to worry about. But we will talk a little bit about that idea when we talk about the not operator, because it's kind of, there's some properties about the not operator that kind of get into that idea of Boolean algebra. But let's go ahead and first focus on the idea of the not operator. So in the case of the not operator, which again is given by the word not, and also you'll notice that I have parentheses here. Basically, if you have the not operator involved, then you're telling the computer to look for a condition that fails. So in the case of just this condition in line 5, which is kind of in contrast to that, here we're asking if x is in fact equal to 10, and we can definitely see that is the case by visual inspection. X is in fact equal to 10. Since that condition is true, then this entire thing is true. We only have one condition. This is just a simple if statement like we had before. So just like any other if statement, that's going to run the indentation here on line 6. Now here on line 8, we have the same condition that we have up here, but we have the not in front of it. And we put the not in front of a condition, or we put a not around the condition. So by around, I mean using the parentheses here to encompass the condition in question. By putting the not here, instead of requiring this to be true, by including the not here, I'm requiring this condition to fail in order for the entire thing to actually be true. So here, in order for the computer to run this indentation on line 9, this condition enclosed in the not operator has to fail. And in this case, with x being equal to 10, we can see for ourselves that this condition doesn't fail. So that means the answer to this question on line 8 is a big no. So that means the computer is going to ignore the indentation that appears on line 9. And that is in contrast to what we have here on line 11, asking if here we're requiring the condition x equals 15 to not be true. And in doing that, in this particular case, we have a variable x is equal to 10. We can see that from a visual inspection. So if we're requiring this condition to fail in order for the answer to this entire if statement to be true, then in this case, we actually have that. In this case, 10 is not equal to 15. And by using the not here, we require this entire thing to fail, or this thing enclosed in the parentheses to fail in order for the entire condition in the if statement to be met. So since x is not equal to 15, this answer to the entire if statement is in fact true, so that means we will run whatever's indented directly below it, just like any other if statement. So based on the logic that we've deduced here, we should expect the computer to print out that's 1. This fails, something we established earlier, and this should be met. So that means the computer should print out that's 1 and that's 3. And if we want to, we can verify that for ourselves, and lo and behold, there is the result that we expect. Now, there's some interesting properties about the not operator, which we can sort of talk about here. So if you have, this kind of goes to the idea of a double negative. So if you have these two conditions here, so I'll even go ahead and put this down on line 11 as well. If you use the not operator twice, then you basically have a double negative here. So you're requiring that this condition fails, but you're requiring this condition to fail, but then you're also requiring this condition to fail. So if this condition fails and the failure of this condition is a requirement of this entire thing is a requirement, then this is basically the same thing as just asking if x is equal to 10. Put in a little bit more of a plain English sentence, you're basically asking here on line 8 if x is not equal to 10. So if you end up having two nots involved, then you're basically having two Boolean operators that are actually canceling each other out. One property that is a little bit more interesting, though, and if we want to actually prove this to be true, then we have to get more into the Boolean algebra side of things. But for now, you can just sort of take this as being true without having to verify it for yourself. But it turns out if you have two conditions, sort of like what we had before. So here I have something like, so here I have the usage of the OR operator here, so I'm requiring just one of these conditions to be true. But by having the not out in front, then I require this entire enclosure between the parentheses, I require that entire thing to fail in order for the computer to actually act on the indentation that appears below here. But if you go through the exercise, you can actually show that these two things are actually equivalent. So this, if you go through the exercise and all the Boolean algebra that's involved, again, I'm not going to do that here because it's not overly important. You can just sort of accept this as being true. But it turns out that this condition on line 8 is actually the same exact question that we're asking on line 11. And if we want to actually see what this looks like when we go to run this, you can see x is, so let's say, so this is something that we have left over, but let's start changing this value of x around. So here I'll say x equals 15, and this time I get no output because this condition up here failed. But now I'll try x equals 11. And now you'll see I actually get the same exact result here. Both this condition ended up, the entire this entire condition in the if statement ended up being true, and this entire condition in the if statement also ended up being true. And sort of on the flip side of that, if you have this instead, it turns out that is logically equivalent to this. So not x, or not condition 1 and condition 2 is the same thing as saying not condition 1 parentheses or not condition 2 parentheses. And again, if you want to go through the exercise of verifying this, then that's just an exercise in Boolean algebra. But this is just sort of illustrate one of the properties of the not operator, which is something you could maybe end up encountering, but usually the logic behind Boolean logic is intuitive enough and self-explanatory enough that it's not something that you're going to need to overly concern yourself with. But that's a look at the not operator and a brief look at, or a brief explanation of the useless Zor XOR operator. But that's going to do it for the Boolean operators portion of this weekly unit. And the next segment, we're going to take a look at the idea of a Boolean variable. So with that, I will see you all in the next segment.